So what we tried to do here was set up a sort of a sequence as we would in person about learning about techniques, learning about what organic chemistry is about, how do we purify stuff, how do we isolate stuff, and then build up the workflow. Most organic experiments are the same when you go into a research lab. You put things together, you monitor them, you work out if the reaction's finished, you isolate stuff, and then you purify it, and then you characterize it. So we're trying to build a workflow for the students to grab a hold of. So I'll talk about some of those experiments we did, particularly with Beyond Labs. And then the more challenging part of this was going to be the synthesis component. How do we do that? Now, in my class, I tried to keep my lecture and my lab in sequence. We require the students to take the lab and the lecture at the same time so that they are learning the lecture material and the lab material together. So we see the application because it is very much a practical subject. So this is an example of the beginning. This is solubility. We did some solubility kitchen experiments with some basic cooking materials. And then we did this where we chose a group of compounds from Beyond Labs that exemplified different functional groups and different polarities of molecules. And then we borrowed from the qualitative analysis section some of the solvents that were available. Now, sodium iodide and acetone, we used acetone as a solvent. We ignored the sodium iodide, and we chose some of the substrates that would not react with sodium iodide, and this worked. So aqueous sodium hydroxide and also aqueous HCl are setting up for the extraction experiment, where their knowledge and solubility has to be taken forward to then think about a separatory funnel experiment, and then deciding where the material is going to go in terms of the set funnel. So this was great because it's the first introduction to Beyond Labs that they saw. It's in the qualitative analysis section, which is stripped down and easier to use than the synthesis section. So we got them started here, and they were able to take materials from the shelf and put them into flasks. And then the very clever videos were really well received, that they can see the actual dissolution as things go. So I put together a few little videos here about how we use this. This was basically get used to how the workflow, or how I should say the actual Beyond Labs work. How do you use the spatula to put material in the flask? How do you get it onto the stir plate? And then we borrowed sodium iodide and acetone. You can see dissolution. The students took screenshots to record this material, then put it into their lab reports. And this was great because we could then change things up. They were getting used to how this worked. We took benzoic acid as a simple example, and thinking again about organic moving into the separatory funnel work and thinking about extractions. If they use aqueous HCl, it should not dissolve, it doesn't. So that was nice, and they can see that. But then if they do the last experiment here, which was, I believe, using sodium hydroxide, they're going to get chemistry. And at this point in the lecture, they're learning about acids and bases. And now all of a sudden they're doing an acid-base reaction in a solubility experiment, as we would do in person. And they have to answer the question, why is this stuff dissolving? So now we're getting some chemistry as well as the physical process, and it's building up to what comes next, and what in a little bit here, which is the idea of extraction. So this was good. This is a nice way to get started. And I think I'll be using something like this in the future to set them up for actual work in the lab. So we also built then into an extraction type thing. This is still solubility and miscibility. We've got ether on the shelf, we've got ethanol, we've got water, we've got some different polarities. We've got polar aprotic and polar protic, as we would in the organic lab. And we started thinking about how can we make the students get this idea of miscibility and solubility in preparation for extraction. So they have the three solutions at the front, and they were given a bunch of compounds just to play with. For example, here's benzoic acid, and see what happens, and find out where your compound goes in the aqueous layer, because that's always a problem for kids. They can't visualize where things are if both the layers are colorless. So this worked very nicely. Again, they had to think about why a salt goes into the aqueous layer, even if it's an organic compound. Now, we talked about crystallization, and crystallization, in my experience, is always done badly. Students just don't understand crystallization. So we wanted to take our time here and give them something to think about. We did a kitchen crystallization of salt and table sugar, and you could tell there was lack of patience, and they weren't really getting the idea. Some did really well, but some not, which was in line with what we always see in the lab. So then we also decided to do a Beyond Labs experiment. We didn't really care about the chemistry at this point because we hadn't covered it. It was the process. How do you get your stuff out of your flask? So this was okay. This was something that we did for recrystallization. They got used to the crystallizing dish. They got used to the melting point apparatus and recording what they did. So we're building up, and they're recording their data and getting used to how this all works. So extraction and distillation, again, somewhat confusing, somewhat difficult to do online, but we did some kitchen stuff with cooking oil and salt and butter, and they reported this, and it was fun, and it was okay. But then we decided that Beyond Labs would be useful for getting used to for synthesis. So for example, in the extraction experiment, we've just borrowed from what we did with solubility. and we gave them some compounds to play with, and they got different compounds all mixed up, and they were to report what happened. And then for the distillation, that was fairly straightforward because we just quenched phenylmagnesium bromide from the Grignard experiment. That gave us benzene, and we distilled benzene. So you've got now this buildup, and they're used to that equipment, all in little segments without all doing it at once and getting lost. They've done this in individual segments, and now they're starting to understand what's happening. So then it started to get fun. TLC, I love the TLC in Beyond Labs. I think it's really clever. I think it really works. In terms of polarities, in terms of purification, in terms of analysis, we linked everything. We didn't use a textbook this year. We linked everything to LibreText out in California online. They have some really, really nice pages that explain all these techniques. And we borrowed from different places about how TLC works. But then we had them think about RF and think about polarities, how that relates to where the compound was shown on a TLC plate. So we did this in Beyond Labs, and we were able to run, in this case, a random experiment, the nitration of benzaldehyde. We hadn't done the chemistry yet, but they can start to see now that TLC tells me there's something in that flask. And it gives them an idea of relative the polarity of what's in that flask. And they can start thinking maybe about where things are going to go when I do that workup. So this was great. This worked nicely, and the students seem to enjoy this because now all of a sudden they're seeing it put together. They're seeing the greater whole. At the end of the first term, we're ready for synthesis. We are thinking now about doing the SM1, the SM2, the E1, the E2. We have, I'll talk about reports in a second. I do have reports coming up. Somebody's asked a question about reports. These are classic reactions that are done in the first semester at the end to get students ready for the second semester. So we wanted to do them in the lab. And this was a great experience because the students had to think. We did some directed reactions where we said, go do this, and what do you see? And towards the end of the term, we started taking the leash off and said, just go find out and start experimenting. And you cannot do that in an undergraduate lab, at least with TAs doing this. So this worked very nicely. I'll give you one example of a sheet that we did, one example of a reaction that we have here, and we're ready to go. So this is my worksheet for alkyl halides. I did, again, I appreciated having the setup labs from Beyond Labs, but we are thinking of using this again in our curriculum for the future. So I wrote them all myself. And we decided that, yeah, let's do some multi-step stuff. Let's turn alcohols into alkyl halides. Let's turn alkyl halides into organic products. Start building this idea of synthesis. So we, at this stage, started to recognize that, well, one of the big things about doing stuff online is safety and the lack of appreciation of safety in an organic lab. So we had to build something in here that would go wrong. And boy, can things go wrong if you set it up right. So reactions of alcohols. We have chlorinating agents on the front bench, right? So here I've got the chlorinating agent. I'm going to take cyclohexanol. I'm going to put it in my flask. I'm going to put some polyprotic solvent in like ether, put it on the front bench. And I'm going to use AlCl3. It's a catalyst for Friedel-Crafts alkylations. But when you put it together like this, boom, it blows up. Why does it blow up? Well, the ALO bond is so strong, it's very ectothermic. So then the students play around with this and start recognizing that it isn't as sort of straightforward as they think. It's not just click, click, click. It's click and think. So they drag this again to the front bench. They're going to add, in this case, SOCl2, which is a universal halogenating agent for organic materials. But we made mistakes. They forgot to put the needle on. SO2 is a gas, right? It blows up. So they learn the mistakes and then they fix them. They have to explain what the mistake was. And then finally, of course, if we run this with SOCl2 at room temperature with a vent, we have no problem whatsoever, and we get a nice reaction. And you can see on the right-hand side, the TLC again shows the relative polarities of these things in a very nice way, which students start to appreciate. All right, so somebody asked the question about reports. What did we do? I probably overdid it, to be honest with you. These kids are stressed, but they succeeded. We asked them to do a report for everything they did. And in the first semester, it's worth 10 points each report. In my class, in the second semester, it's worth 20 points. This is the data table that the kids would typically put together before they did a lab. These are the compounds they were told they were going to be using. They went to PubChem, and they found all the melting points, the boiling points. They found all of the safety data information, and they put it together into this. So no, it's not. We're not just filling in blanks. We're actually writing reports. And these got better and better as the term went on. Then the students would be writing procedures, third person past tense, all this stuff. This took a while to get them used to it because they came from general chemistry, not to put anything against general chemistry, but at our place, they were doing fill-in sheets. They would just hand something in, that was it. Here, we're trying to teach them how to do professional reports. So at the top, we've got the procedure, very nicely done, organized. At the bottom, we've got the evidence, we've got some consideration, we've got screenshots of Beyond Labs as evidence for what they did. And then they had to put together their preferred protocols. This was something that we really enjoyed doing, was preferred protocols. How do you think we're going to do this? Or what is the best method for doing this? Then at the bottom, conclusions. Every lab report should contain a conclusion, and they got better and better as the year went on, which is really nice.